I just woke up today and a realization hit me. When I hear the word dirty, I'm thinking dirty bulk. And I know some of y'all do, my gym bros and gym gals. Dirty could also mean the good stuff. Now we're talking dirty brown sugar milk tea. It saddens my heart to hear the word dirty could mean something really, really bad, especially when we're talking within the Linux ecosystem. Apparently, there's been a family of bad dirties in the Linux system across multiple distros, regardless of whatever you're on. You could be on your Ubuntu, Debian, you could be affected. So none of these is safe. And this family has four dirty kids. And today we're going to be talking about the last dirty child, which apparently has been out since 2017. And we're only getting some awareness on it since Frog released an article about it not too long ago, in May of this year. So what do we have here? Dirty Clone is a new Linux kernel privilege escalation in the Dirty Frag family. So JFrog Security Research published a working exploit walkthrough for the flaw on June 25th, the first public demonstration for this variant. It extracts the CVE 2026-43503 and it lets a local user corrupt file-backed memory through a cloned network packet and gain root access. The patch landed mainline in May 21st, and if your kernel does not have it, update it now. I'm going to welcome my buddy Daniel, who knows a little more about this than I do, and he's going to lead us through and walk us through exactly how this works. So, what do you think about all this, Danzzy? And I know you probably destroyed, sad about how dirty could be bad as much as I do. So, what do you know? Let's hear from you.
Yeah, so Mani, thank you for the intro. And I mean, this is a vulnerability that anyone that uses the Linux kernel needs to take seriously. And with the way this vulnerability works, usually we have different categories of storage. We have SSD or your HDD. Another category would be your RAM, where information is stored for data that is being processed immediately, right? Now, with the RAM, the way it works, it has a section in it that is called a page cache that stores data or information that's being used by multiple processes at a time, right? So you may have some form of executable binary files like your ls, your su, sudo user, change 09, all those stuff. You may also have users data and all that in the page cache. Now, with processes, if they try to make changes to any file in the page cache, the Linux kernel would usually create a duplicate somewhere that the process can make changes to it so that it doesn't affect other processes that are used in the file. Yeah, so with the way Daisy clone works is tries to exploit the way the Linux kernel handles information stored in the page cache. Because, for instance, let's say there is a server that is, let me say, working, and users make requests to the server, and the server needs to provide responses back to the users. What would happen is that because this is happening via networks, what the server will try to do is, because the network data transmission has different layers, it tries to run several or multiple activities in parallel so that the response is provided quickly back to the user. So for instance, let's say we have a file that I'm trying to access, right, from a server, let's say in Mani's house, and that server is supposed to provide me with some form of information. Now, because of how sensitive that data is, the server needs to encrypt it. It also needs to check through the firewall policies to ensure that it's allowed to let that file leave the service and environment, right? So what the kernel will do is to duplicate the networking packet that is supposed to transmit, or to make duplicates of it, provide one of the duplicate to the tool that does encryption, provides another duplicate to the tool that is going to check the firewall rules and policies. And during the duplication, the kernel somehow drops a flag that prevents the packet from making writes to your page file. So what happens is that if an attacker is able to gain some form of access to that duplicate packets since it doesn't have the right flag. The attacker is able to make some modifications to the packet and send back that packet to the server. And with what is happening is that means that the kernel is going to automatically accept the rights to the page file since that flag wasn't there. And so, for instance, what will happen is that if you have an SU file, the switch user file, that allows you to switch to your root user or your admin user, it means that once those changes are made to the SU file, anyone that tries to run the SU again is going to have an access of the modified file. And so it means that the user will now have access to roots even without probably having permissions for that.
That seems like a lot of damage that could potentially happen because we all know how having root user account access on your Linux system could be very, very, very bad. So, how do we remediate, or how do Linux users go about making sure their systems are protected and making sure this doesn't happen to them?
Yeah. So, I mean, before JFrog released or notified the public about this vulnerability, they decided to disclose it to the maintainers of Linux, the various Linux distros. So most of them have started working on it and also patching it up. So the first thing you can do is quickly you need to go and update your system. Go check for updates. Make sure your PC is up to date. And once you're done with the update, it doesn't end there. You need to do a restart. That is important because the file has been modified on your RAM, but not on the SSD. And so even if you do the updates, your vulnerable file still sits on the RAM. And because you haven't restarted it, there's no way of the system picking up the new updates and clearing off any form of modified changes to the file.
All right, thank you, Danzzy. So yeah, that'll be it. If you are on any Linux system, whatever distro you have, this is definitely going to apply to you. So especially if yours came after 2017, you definitely want to make sure you're locked in, put in all these protective measures, and stay tuned. And that's what we wanted to chat about today. And we are hoping to catch you again sometime in the future. And like we always say, we want to cover stuff that matters the most to you. So you could always reach out, put it down here in the comments, or reach out with whatever topics you have that you want to see us cover in next coverings of this video. So stay tuned and peace out.